I'm going to discuss with you about the topic of linear regression. Basically, this is required whenever two variables which are linearly correlated, and when we plot the points on a scatter diagram, we observe that there is a straight line which can fit, or the points are clustering around that straight line, and that straight line can be used for predicting variables, and that's why it is called a regression line. Now we are going to learn how many regression lines are possible. So since there are two variables, so we can find two regression lines. These are also known as estimating lines, predicting lines. So one is known as x on y, the second is y on x. What does it mean? When I say x on y, we are going to use this line when we want to estimate or predict the value of x when y is given. Why? Because here x depends upon the value of y. So y is independent, x is dependent. So this is known as x on y. In the same way, let's say if we want to predict the value of y and x is given, means when we say y depends upon the value of x, this is called y on x. So you can see from here in the diagram. So there are two ways we can fit a line. Either we can fit a line where y inputs and where x is input and y is an output, and we can also create or fit a line which is called x on y. In this case, now y is input and x is output. So these are the two lines which can be used for predicting x and y. So second point is how to find what are the equations. So regression equations, the first one y on x here written. So the formula to find a y on x is this one: y minus y bar is equals to b by x, x minus x bar. Here y bar and x bar are mean of y variable and x variable data. So that can be done as a usual way. Now there is a one more term, b by x. This term is known as a regression coefficient, and this regression coefficient is y on x line. That's why y is written first and x is written later in a subscript. So this is a notation for the coefficient in the line of y on x. Now we are going to see how we will calculate this coefficient. So there is a number one formula which we can see, that when b by x is the ratio of covariance upon variance. Now we know how to find covariance using a average technique, expectation, or we can substitute the value of expectation of x and y means average of x and y. Expectation of x means mean of x, and mean of expectation of y is mean of y. So when we substitute, and denominator is the variance, and we know that variance is e of x square minus ex whole square, or in terms of summation we can write like that. So for example, when we are given with a data where summation of x is available, summation of y can be possible, product is possible, square is possible, we can use this format. And after simplification also we can rewrite the formula. So this can be rewritten, we can use any one of them. Now second thing is, sometimes the direct value of r is available and the standard deviation are available, and we know that in the formula of correlation we get sigma xy value. So we can retrieve the value of sigma xy in terms of these values, and after simplification our formula can be modified. So there are two ways we can find out this b by x. So either you can use the summation notation, or we can use this r sigma y upon sigma x. In the same manner, we can also find the regression equation of x on y. Here x minus x bar is on the left side and y minus y bar is on the right hand side, and there is a coefficient bxy which is a regression coefficient. Here also, since the line is x on y, so we write bxy. Same way we can write a formula. When we say x on y, we get a variance of y in the denominator, and when we say y on x, the variance of x is in the denominator. Whatever we write a later variable, that variance is in the denominator. Numerator is same for both. So in the same manner we can find out the ratio of these two terms, and after simplification our formula can also be used. So here also, if r sigma x sigma y, three values are given, we can use correlation formula to rewrite as a r times sigma x upon sigma y. So you can see x is written first, numerator is sigma x, y is written later, denominator is sigma y. So these are the two formulas. Now we are going to take two examples. In one, I will use this formula, the new first one, and in second example we will use the second formula. So let us see the example. Now here the example number one is to find two equations which are regression lines, y on x and x on y. Now here the data values are given. So sometimes the data of x and y are given. We have to find sum of x, sum of y, sum of product, and x square, y square as per the lines. Now let us see how we can find out. They have also asked us to estimate the value of x when y is given. So the point number one is that to recall the formula. So we are going to recall these two lines formula. Y on x is this line and x on y is the second line. So let us begin with the one by one. Before that, we know that in both the line there is a common term which is a mean. So let us find out what is x bar. X bar is sum of x divided by n, and we know that sum of x here is given as 250. So we are going to write down 250 divided by 10. So we are getting 25 as an x bar. Similarly, we can also find out y bar, which is sum of y upon n, and sum of y is given to us as a 300. So we are going to plug in the value of 300 upon 10, which is 30. So we got x bar y bar. It means now we left with the byx value and bxy. So one by one let us find out. For that we know the numerator part is common for both the lines, means for both the coefficients. So we are, the one way is you can calculate them separately and then put it into the formula. So I am going to calculate here summation of x, y divided by n minus summation of x upon n, summation of y upon n. And we know that summation of this is actually mean of x and this is mean of y. So we have already calculated mean of x, mean of y, and let us see what is product, 7900. So we are going to put 7900 divided by 10, and here x bar is already created, which is 25, into y bar we have calculated, which is 30. Now here when we simplify, we are getting this value as a 790 minus 750, and the answer for the covariance is 40. So we got a covariance value as a 40. So the numerator for both the byx and bxy is calculated. Now let us see the variance. For a variance, we will take a sum of squares entries average, average of this, minus. Now you are observing that ex is nothing but sum of x upon n. So it means that is sum of x upon n to the power whole square. And sum of x square here is given as a 6500. So we are going to find 6500 divided by 10 minus, and this value we have already calculated, 25 square. So this is 650 minus 625 square is 625, and when we simplify it we get 25. So we got a variance of x as a 25. Now let us find out the variance of y. So y square is given as 10,000. So it means we need to find out sum of y square average and sum of y square, which is 10,000 upon 10 minus, we have already calculated 30 because this is mean. So we can simplify it. There is a 1 0 cancel. So we are getting 1000 minus 900. And 1000 minus 900 is 100. So we got the value of variance. So what we can do, instead of finding the direct formula, we can use the numerator once and then variance once, and then we can put it into the formula. Now we are ready with the lines. So let us write down first y on x. When I say y on x means y minus y bar is on the one side, equal to then the regression coefficient b by x and x minus x bar. Now plug in the value. Y minus y bar means 30, and we know that what is b by x. This is covariance of xy upon variance of x, and x minus 25. Now we can plug in the value of y minus 30 is equals to, we got a covariance 40 and variance of x is 25. So it is 40 upon 25, and this is x minus 25. So we are getting, this is going with 8 and this will go with a 5, and even if I simplify, that will be 1.6. So we are getting y minus 30 is equals to, so 1.6, when I multiply, it will be 1.6 times x minus 1.6 into 25. We are going to get it over here as a minus 40. Now since everything is evaluated, we can write, there are two constant, we can shift it on the other side. Minus 40 is here and plus 30. So we got a regression line of y on x as y is equals to 1.6x minus 10. So this is our first line, which is an estimating line for this is y on x. In the same way, we can find out x on y. X on y means x minus x bar on one side, b of xy, and y minus y bar. So we know that b of xy is equals to covariance of x y divided by variance of y, and we have already calculated x bar is equals to 25. B of xy covariance is 40, that is numerator is same for both. Denominator for variance is now 100. We can see once again. So yes, we got variance of y as 100 and y minus 30. So we are observing here we get a 0.4. So x minus 25 is equals to 0.4 times y minus 30. And when we simplify, x minus 25 is equals to 0.4 y. When we simplify, 0.4 into 3 is 12. So now we are going to shift this 25 on one side, minus 12. After simplification, we are getting x is equals to 0.4 y plus 13. So that we are getting the equation of x on y. Now let's see, there is a one more question. They said estimate x when y is 5. That means we want to find x when y is given. So x on y line is, because y is available, based on y we are calculating x. So x on y, x depends upon y. So x on y we have to use by putting y is equals to 5. So we saw x on y line is, yes, the same line. So for y is equals to 5, we are going to find x. So when we put y is equals to 5, that's 4. Y is equals to 5 plus 13. So we know that 0.4 into 5 is 2 plus 13. So answer is equals to 15. So we are getting x is equals to, for y is equals to 5, x is equals to 15. So in this manner we can calculate this question. So now let us see the second one. Now I have taken the second one of the different model. Now what happened here? Here the study of a price of a rice Chennai and Madurai is given. So here what is given? The direct mean is given and standard deviation of given for the price of rice at the two places. So the two places are Chennai and Madurai. So first of all, let us use the mathematical notation. We can call Chennai price of rice as an X and Madurai price of rice as an Y. So here what is given? X bar is given and standard deviation means sigma of x is given. Here y bar is given and standard deviation of y is given. And one more thing is available, correlation coefficient between price of two cities, rice in two cities is 0.8. So R is given. Now we can see that the question is about estimating. So there are two parts of the question. They are asking find the most likely price of rice at Chennai corresponding to the Madurai. Chennai means X and Madurai rate is Y. And Madurai is Y and Chennai rate is X. That means predict X for a given Y. So here we use X on Y and predict y when x is given, so we use y on x. So it means both the equations are required, but this time we are going to use the formula. We can use this formula. So for x on y, we know this line, we have already used it in the previous question, but this time we are going to use the other formula or a simplified formula. Here in this formula, standard deviation and correlation is available. So we can put this formula here and now directly substitute the answer. So we can get that x minus x bar. So we can see what is x bar here. X bar is 19.5 and y bar is 17.75. Sigma x is 1.75 and sigma y is 2.5 and r is 8. So let us put in the value. So x bar over here is 19.5. R is 0.8, standard deviation of X is 1.75 and standard deviation of Y is 2.5. Let us check once again. X is 1.75 upon 2.5 and then we have a Y minus Y bar and Y bar is given to us is 17.75. Now we are going to simplify it. We can simplify the outer value first. Let us see, when we multiply 0.8 with 1.7, we are getting this value. After multiplying these two values, we are getting 1.4. And once we are done with it, we are getting here, we can put it 19.5 here is equals to 1.4, it's 14 by 25 and y minus, this side it is plus 17.75. So what we can do in this stage, because in this question they are only asking us to estimate the value, so no need of finding the equation, we can put the value. We can say that for y is equals to, so what is y given to us? Y is equals to 18. For y is equals to 18, what is x? X is equals to 19.5 plus 14 by 25. Y we can substitute here as an 18 minus 17.75. So what we can do when we simplify this value, we are observing this is equals to 19.5 plus 14 by 25. When we take a difference of 18 and 17.75, we are getting 0.25. So here this decimal we can do it like 100, 25, 25 will get cancelled. So we are almost near to the answer. 14 upon 100 can be written as 0.14 and when we add it we are getting 19.64. So we observe that the price of rice for y is equals to, when the price at Madurai is 18, at that time we can predict the price at Chennai is 19.64. Now in the same manner we can find the second one. It is saying what is the price at Madurai when the price at Chennai is 17. So we are going to use the second equation, which is y on x. So that means, let us see, equation is already written, so we are going to just plug in the value. So y minus y bar. What is y bar? Y bar 17.75, 19.5. The answer is in point. 17.75. R is 0.8 and sigma of y is 2.5, 1.75, and x minus x bar is 19.5. Now, because we are interested to estimate the value of y when x is equals to 17 here. X is equals to 17. So, for x is equals to 17, we can plug in the value. We can shift this number on the other side. First of all, when I multiply these two numbers, we are getting 0.8 into 25 is equals to 2. So it means when we shift this number, on the other side it will be plus 17.75. This side we have a plus 2 upon 1.75, and when we are putting the value of 17 here, because we are estimating y for this x value, so we can directly put it over here. And after simplification we are getting y is equals to 17.75. When we take a difference, this difference is coming out to be minus 2.5. So we are getting this value, and after simplification we are getting minus 5 upon 1.75. We can multiply 2 into 2.5, which is 5 because 1 is negative, so that value, and 17.75. When we take a calculator and after dividing 5 with 1.75, we get 2.86. So it means after simplification we can find this value as a 14.89 approximately. So we have predicted the value of y 14.89 price of rice when that is at the Madurai, when the price of rice at Chennai is 17. So I hope you got an idea where to use which formula, and these are the two way we can uh, find the question of a regression line. So thank you for watching.